Pre-trained base LLMs are great for next token prediction. But if you want them to follow some instructions or if you want them to align with some preferences according to your own data, then you need to fine tune these LLMs. There are mainly three types of fine tuning techniques. There is full fine tuning, where you update the whole array of weights of a model as per your own data. Then we have a LoRa, where you just freeze all the weights of the models and then you put some adapters on some layers and then you only train those adapters or fine tune those adapters as per your own data. And then we have QLoRa, which is a quantized LoRa, where instead of full precision of the whole weights of the models, we just quantize those weights, which affect some of the accuracy, but it improves the resource requirements. Now we have a new technique called as Turbo LoRa from Predibase. Turbo LoRa is a new parameter efficient fine tuning method they have developed at Predibase that increases text generation throughput by 2 to 3 times while simultaneously achieving task specific response quality in line with low rank adaptation or LoRa. While existing fine tuning methods only focus on improving response quality, but they suffer from lower throughput. That is where Turbo LoRa is trying to help out by improving throughput over both standard LoRa and even the base model. This means lower inference cost and lower latency and higher accuracy, all in a single adapter that can be created with just one line of code at Predibase, and they have shared some of the code chunks here. Now, the downside is that as far as I can see, this is not an open source thing. Also, doesn't seem like it is a free thing. You would need to use either Predibase console or you would need to use their SDK to get this working. They do give you around $25 of free credit once you first sign up, but that's about it. Then you would have to pay them to get this working, which is, well, I would leave it to you whether you use it or not. But it's not that you could just go to GitHub, git clone their repo, and just get your own data set, use it on any model, and then go from there. All local, all private. I think you would need to use their SDK and their console, either one of them, to get this working. But other than that, if you are willing to do that, seems quite an interesting idea. Maybe someone could clone it, fork it, and then just give us an open source version. Who knows these days? Now, if you look at some of the architectural stuff here, that is quite interesting. We all know that low rank adaptation or LoRa has become the de facto standard approach for fine tuning LLMs to perform well on specific tasks. Because LoRa has a very small memory footprint compared to the base LLMs, um, and we can create hundreds of LoRa adapters on single GPU. And then there is a tool called as LoRaX, which I already have covered on the channel, which enables you to have multi LoRa inferences. So, but one of the concern around using LoRa in production is the speed, because LoRa introduces additional parameters to the model by freezing actual weights, and then these parameters, the new parameters, adapters have to be activated at each layer. So it also increases the time to generate each token. And then merging the LoRa weights back into the base model addresses the speed concern but negates all the other benefits of LoRa during inference, which primarily means the ability to serve multiple tasks simultaneously on the same deployment. So you can see in this diagram that LoRa adapts LLM to improve response quality by inserting new parameters alongside existing layers, most commonly, of course, query, key and value projections. So, by the way, the LoRaX framework which I just mentioned, I believe that is also from Predibase, which is quite good, and that is open source. So really, the credit goes to them for making it open source. Now, if you look at this diagram, this is where they are just talking about some of the speculative decoding here. So this is where they are using the assisted generation, using a smaller assistant model to generate speculative token and then using the LLM for verification. And then There is another technique which is called as Medusa, which is a more recent technique that replaces the assistant model with a set of additional layers added to the original LLM called Medusa heads, and I already have covered it on the channel. In this Medusa, each head takes as input the last hidden state from the transformer layer of the model, passes it through a multi-layer perceptron block, and then finally a fine-tuned replica of LM head to produce the speculative logits, which is the raw output of the model. So in this one, Medusa is adapting the LLM by inserting new layers at the end of the LLM that sit alongside the LM head. Every Medusa head replicates the base model LM head, introducing significant memory head. So this is where enters Turbo LoRa. Now, in this one, you can see that Turbo LoRa is jointly learning a set of LoRa parameters to improve response quality with a small set of linear projections to generate speculative tokens. The base model LM head is reused. So, Turbo LoRa is primarily combining the model quality benefits of LoRa with the high throughput of speculative decoding. By jointly training both the LoRa adapter and the speculation adapter at once, they are taking advantage of the more narrow and specific output from training the LoRa to improve speculative quality. In a sense, the more constrained the output, the easier it is to predict future token, and that is where Turbo LoRa is really proving to be parameter efficient. And the number of new parameters introduced by Turbo LoRa is about 1% of number of parameter introduced by Medusa, which is quite good. And then towards the end, the output of all of these streams are fused together for a single pass through the LM head to generate logits up to n tokens ahead. So all in all, real good stuff. As I mentioned that you can use it in your code too. Let me quickly show you their SDK code example. So after installing the Predibase, which is simply pip install Predibase, and then you can also follow this link from here, and I will drop the link to this blog post from Predibase in video's description too. So first you install Predibase with pip, and then you just import it. From there you get the client, you go to predibase.com, grab your API token. If you already have consumed your $25, you would have to pay them. And then from there, you just grab your data set. You can use your own. As you can see here, they are using the CSV file. And then you can put in some observability optional. But in order to use it, all you need to do is to just create an adapter repository, then start your fine tuning job with this one command where you are giving it your data set, your above repo, which base model you are using to fine tune with this Turbo LoRa, and that's about it. And it is going to create the adapter for you. And then you can even monitor your job here. Once you have monitored it, you can do the inference or whatever you like. So all in all, seems quite good. I really hope that they would either make it open source or would give more credit rather than just $25 so that we could just at least try it out. So that's it guys. I hope that you enjoyed it. Let me know what do you think. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thanks for watching.